So basically, binomial theorem is x plus a the whole to the power n is nc0 x to the power n a to the power 0, n minus 0 is n, a to the power 0, plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2. So general term is ncr x to the power n minus r a to the power r. The last term is ncn x to the power n minus n, which is 0, a to the power 0. See, x power is coming in descending order. Can you see? And a's power is going in ascending order, a to the power n. So then x minus a the whole to the power n is nc0 x to the power n a to the power 0 minus nc1, alternatively negative sign, x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 minus nc3 x to the power n minus 3 a to the power 3. So general term is ncr x to the power n minus r a to the power r. I don't know whether to put this as positive or negative, but depending on r, if it's odd, so put minus 1 whole to the power r. Similarly, minus 1 whole to the power n, last term is ncn x to the power 0 a to the power n. Now let's add these terms x plus a the whole to the power n, x minus a the whole to the power n. When you add these two terms, you know the alternative terms are getting cancelled. That is, the one which has got r as 1, r as 3 will get cancelled. So 2 times, because we are adding this and this, it's 2 times nc0 plus nc2 plus nc4 dot dot dot. nc0 is x to the power n minus 0 a to the power 0, x to the power n minus 2 a to the power 2, x to the power n minus 4 a to the power 4, and so on. So if you want to subtract x plus a the whole to the power n minus x minus a the whole to the power n 2 times, you know that it will be 2 times nc1, nc3, nc5 and all will remain, x to the power n minus 1 a to the power 1, x to the power n minus 3 a to the power 3, x to the power n minus 5 a to the power 5. You know, subtract this and write this power. Okay, so then that's about it. That's in subtraction. I'm going to do some textbook sums. This is 6th sum. 96 the whole to the power 3, you can write it as 100 minus 4 the whole to the power 3, and you can apply the formula x minus a whole to the power n is 3, hence n is 3, x is 100, a is 4, nc0 100 to the power 0, 4 to the power 100 to the power 3, 4 to the power 0 plus 3c1 nc1 100 to the power 2 descending order, or subtract and write it, 4 to the power 1 plus 3c2 100 to the power 1 4 to the power 2. So next is 3c3 100 to the power 0, 4 to the power 3. So that's let's solve this. This is just 1, 3c0, and so this is 1, the 100 to the power 3 is double 0 once, 2 is 1 twice, 1 2 3. So that's the answer. 3c1 itself is 3, 4 3s are 12, and double 0 double 0. Okay, this 3c2 is 3 into 2 by 2, n into n minus 1 by 2, or you can use n factorial by n minus r factorial, or mug up n into n minus 1 by 2, so it's 3. So 3 4 is 16, 16 3s are 48, double 0 plus 3c3, or you can write 3c2 is the same as 3c1 because ncr is the same as ncn minus r. So 3c2 is also 3, 3c1 is also 3. So so it's done, and this is 3c0 which is the same as 3c3, and 3c0 are the same, ncr is the same as ncn minus r. So it's 4 to the power 3, right? And this 100 to the power 0 is 1. This is also 1. So 4 4 16, 16 4 64, 64 4 sir. No, 6, oh, that's all. So just add it and write your answers. Check for your back answers. That's a 7th question. 102 whole to the power 5, which is 100 plus 2 whole to the power 5. There's no alternative negative sign. In this there's alternative negative sign because of this minus. It is 5c0 100 to the power 5, 2 to the power 0. 5c1 100 to the power 4, 2 to the power 1 plus 5c2 100 to the power 3 2 to the power 2 plus 5c3 100 to the power subtraction, right, 2 2 to the power 3 plus 5c4 100 to the power, have doubt, subtract and see, so 2 to the power 4 plus 5c5 100 to the power 0 2 to the power 5. So you have to expand, you have expanded this, you have to find the answers for this. 5c0 is 1, 2 to the power 0 is also 1, so 1 2 3 4 5 plus 5c1 is 5, 5 2s are 10, and 100 to the power 4 is like 1 2 3 4. Then 5c2, you should know 5c2 is 5 into 4 by 2 is 10. Otherwise you can use n factorial by n minus r factorial to r factorial, but I prefer 5c2 is 5 into 4 by 2, n into n minus 1 by 2, 10. So you already have a 10. 10 into 4 is 40. It's a 2 square, right? 40. How many zeros? 1 2 3. Sorry. Next is 5c3. 5c3 is the same as 5c2. NCR is the same as NCN minus R. So you know what is 5c2, right? We just calculated 5c2 to be 10. Take that and write here also. It's 10 and 2 to the 4 is 8, so 80. 100 square is 0000. Plus 5c4 is the same as 5c1. NCR is the same as NCN minus R. So 5c1 is 5. 2 2s are 4, 4 2s are 8, 8 to 16, 16 5s are 80, 00. Plus 2 to the power 5, 2 2s are 4, 4 2s are 8, 8 to 16, 32. These are all just 1, so 32. So just add these answers and write it and check your book back answers. So that's about the 7th question. Let's do the 8th question. 101 the whole to the power 4 is 100 plus 1 the whole to the power 4. It's only with a plus. So it's 4z0, 100 to the power 4. 1 to the power any number can be ignored. Whenever it comes to the 1, I'll ignore it completely. So plus 4c1, 100 to the power 3, plus 4c2, 100 to the power 2, plus 4c3, 100 to the power 1, plus 4c4, 100 to the power 0. So what is 4c4? 4c0 is 1, 100 to the power 4 is 1, 2, 3, 4. Plus 4c4 is 4c1 is 4, 1, 2, 3. Plus 4c2. What is 4c2? Is 4 into 3 by 2 is 6, 1, 2. And 4c3 is the same as 4c1. 4c1 is just 4. So 4 into 100 plus 4c4 is 1. So plus 100 to the power 0 is 1. So that's it. Just add this answer and write your answer. Make a right addition, don't make any mistakes. 9th question, 99 whole to the power 5 is 100 minus 1 whole to the power 5, negative sign, so alternative negative has to come. 5c0 100 to the power 5, 1 to the power any number ignore, minus 5c1 100 to the power 4, 1 to the power any number ignore, plus 5c2 100 to the power 3, minus 5c3 100 to the power 2, you have problem writing power, subtract and see, plus 5c4 100 to the power 1, plus 5c minus 5c5 100 to the power 0. So 5c0 is 1, 100 to the power 5, 1, 2, 3, 4, 5, minus 5c1 is 5, 100 to the power 4, 1, 2, 3, 4, plus 5c2. What is 5c2? 5 into n into n minus 1 by 2, so it's 10. 1, 2, 3. Minus 5c3, NCR is the same as NCN minus R. 5c3 is the same as 5c2. 5c2 is already 10, so this is also 10. 10 into plus 5c4, same as 5c1, which is 5, into 100, so 500. Minus 5c5 is 1. 100 to the power 0 is also 1. Just solve it, you get the answer. Make sure you're remembering to put alternatively negative sign. Let's go to 10th question. 10th question is 1.1 the whole to the power 10,000 or 10 or 1000, which is greater. Let's take this and expand. 1 plus 0.1 the whole to the power 10,000, which is like x plus a whole to the power n. So 10,000 C 0. 1 to the power 10,000, ignore. 0.1 whole to the power 0 is just 1. Plus 10,000 C 1. 1 to the power any number, ignore. 0.1 whole to the power 1. Plus 10,000 C 2. 0.1 whole to the power 2. Because 1 can be ignored, okay, and everything is positive. So 10,000 C n, 0.1 whole to the power n. In this itself, answer is 1, because in NC0 is 1, any number to the power 0 is 1. This is 10,000 and this is 0.1, so 1 by 10 plus these terms such as 10,000 C to 0.1 whole to the power 2 plus dot 10,000 C n 0.1 the whole to the power n. So this itself is 10,001 plus all these things will come here. So this, it's 1001, I'm sorry, 1001, because 1001. Anyway, it's definitely going to be greater than 1000. That's all proved. So let's go to next sum. That's a very important sum, okay? So then a plus b the whole to the power 4 minus a minus b the whole to the power 4. So this is subtraction symbol. We already memorized the formula for x plus a the whole to the power n minus x minus a the whole to the power n. With subtraction, only r is equal to 1, r is equal to 3 and all will come twice. 2 into 4, n is 4, 4c1 plus 4c3. That's all can come here. What is it? A to the power 4 minus 1, 3, b to the power 1, a to the power 4 minus 3, 1, b to the power 3. So that's all. Okay, so that's all will come. So that's the answer. That's all. You can leave it like that. And you know 4c1 and 4c3 are the same. NCR is the same as NCn minus r. Oh, beauty. So 4 a to the power 3b plus 4 a to b cube. So 4 is also common. 4 2s are 8. And ab is also common. So you have a square plus b square or something like that, right? Just check your book back answer after that. Okay, so let's, but the same sum. So I'm sure you understood. They are asking for using this. Hence evaluate. Hence means using that, evaluate. You already know this will become this, where a is root 3, b is root 2. Just put that in the formula. 8 into root 3 into root 2 into a square plus b square. 8 5s are 40, root 3 into root 2 or root 6 is the answer. Check your book back. Just substituting in the final answer. The 12th question, x plus 1 the whole to the power 6 plus x minus 1 the whole to the power 6. You know it's root 2 plus 1 the whole to the power 6 plus root 2 minus 1 whole to the power 6. Hence solve. Hence solve, don't touch it. It is with addition. Addition means you know that NC0 will come twice. 2 times NC0, 6C0 plus 6C2 plus 6C4 plus 6C6. So it's x to the power 6. 1 to the power any number, ignore. X to the power 4. X to the power 2. X to the power 0. Oh, that's all. Okay. So what's this adding up to? 6C0 is 1. X to the power 6. 6C2 is 6 factorial by 4 factorial into 2 factorial, which is 6 into 5 into 4 factorial. 2 3s are 6, it's 15. Or n into n minus 1 into n minus 2 by 6, which is 6 into 5 into 4 by 6, so 20. Whichever way you want to do, you can do. So you know this answer is going to be 62 is 20 into x to the power 4. 64 is the same as 62, so don't do it, just write 20 into x square. 66 is the same as 60, so it's 1. 1 x to the power 0 is also 1. So this is the answer. Hence solve means, you know, x is root 2, x is root 2, that is a is root, in this question, it's x is x only. So x is root 2 and x is 1 only. Based on that only we solved it. So wherever x is, right, root 2 the whole to the power 6 plus 20 into root 2 the whole to the power 4 plus 20 into root 2 the whole square plus 1. Just solve it, you get the answer. Okay, so let's go to the next question. 13th question, very very important question. 9 to the power n plus 1 minus 8n minus 9, is it divisible by 64? So you just have to take this one alone. 8 to the power n plus 1. 9 to the power n plus 1. Write it as 8 plus 1 whole to the power n plus 1. Don't write it as 10 minus 1. So long you are doing that. For calculation is easier. But here you need to be divisible by 64. So necessarily 8 plus 1. That's when you get 64. So instead of n, you have n plus 1. So n plus 1 say 0. 8 to the power n plus 1. 1 to the power any number can be ignored. Plus n plus 1 c 1. 8 to the power n. Plus n plus 1 c2. 8 to the power n minus 1. Plus dot 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 n plus 1 c n plus 1. 8 to the power 0. So n plus 1 c n. 8 to the power 1. All with the plus only. So no problem. But let's write the one more term in front, which is plus dot 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 n plus 1 c n minus 1. 8 to the power 2 obviously. I need till here 3 terms in the front and 3 terms in the back. Why did I do that? I know that. Let's solve it. N plus 1 c0 is 1. 8 to the power n plus 1 plus n plus 1 c1 is n plus 1 into 8 to the power n. Rest of it copy it as it is. N plus 1 c2 8 to the power n minus 1 plus dot 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 n plus 1 c n minus 1 8 square plus this coefficient is last but one term which will have the same coefficient of second one, which is n plus 1 into 8, and this will have as the first one which is 1. So take it in. So you write the same thing in the left side. Please write it as like this. 9 to the power n plus 1 is equal to 8 to the power n plus 1 plus n plus 1 into 8 to the power n plus n plus 1 c2 into 8 to the power n minus 1 plus dot 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 n plus 1 c n minus 1 8 square. Then take it in 8n plus 8 plus 1 is 9. So we're going to take this to the left hand side. So what is going to happen? So 9 to the power n plus 1 minus 8n minus 9. Take these two alone so that you get the question. Magical. And till here, if you see, you can take 8 square out. Till here, from here to here, specifically from here to here, 64 can be taken out because there's an 8 square. This will become 8 to the power reduced by 2. So it will become 8 to the power n, 8 to the power n minus 1. N plus 1 into 8 to the power n minus 1, n minus 2. Plus n plus 1 c2, 8 to the power n minus 2, n minus 3. Plus dot 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 n plus 1 c n minus 1, 64, which has been taken out. So therefore it's 64 into multiple of something. So it's divisible by 64. That's what is this sum. So let's do the 14th question. A summation of r is equal to 0 to n, 3 to the power r, ncr is equal to 4 to the power n. So when you have it like this, r is 0, put r is equal to 0, 3 to the power 0, nc0 is 1. Put r is equal to 1, 3 to the power 1, nc1 is 3. R is equal to 2 is 9, 3 to the power 2, nc2 is nc2. It's just leave it like that. Okay, so these are the this is what you get. So you get the sum to be 3 to the power 0 nc0 plus 3 to the power 1 nc1 plus 3 to the power 2 nc2 and so on, 3 to the power n ncn. And this is the solving of the LHS. Let's solve the RHS. 4 to the power n can be written as 3 plus 1 the whole to the power n, which is nc0, 3 to the power n, which is exactly this. 3 to the power n, 1 to the power 0, nc0, which is 1. Or you can even write it as 1 plus 3 the whole to the power n if you want more convenience. So you will have nc0, 1 to the power n, 3 to the power 0, plus nc1, 1 to the power n minus 1 can be ignored, 3 to the power n minus 1. So let's write this. Let's solve this further. Okay, 3 to the power 0 is 1. nc0 is also 1. 3 nc1. nc1 is n into n minus 1 by 2. Or you can keep it as nc1. And this is nc2. 9 into nc2. Correct. Okay, so it's let's consider this as 3 plus 1 போட்டால் என்ன ஆகும்? nc0 3 to the power n 1 to the power 0 plus nc1 3 to the power n minus 1. 1 to the power any number can always be ignored. nc2 3 to the power n minus 2 plus ncn 3 to the power 0. This is nothing but nc0 3 to the power n. So last term, let's substitute r is equal to n here. With 3 to the power n, ncn 3 to the power 0 ncn. Isn't that the last term in this? The last term in this is same. 3 to the power n. It's got 3 to the power n, but the coefficients are anyway the same, no? They are not exactly the same. If you see, right, the coefficient nc0 is 1, ncn is 1. So it's just 3 to the power n. This is also 3 to the power. This is also 3 to the power n. The first term in this and the last term in this are same. Okay. Plus nc1 is just n. 3 to the power n minus 1. Okay, 3 to the power n minus 1. Which is if you had the previous term. If you had the previous term, and we could have done it as 1 plus 3 the whole to the power n, then that would have been easy. 1 second, hold on. That would be easier for you. So it's nc0, 1 to the power any number ignored, 3 to the power 0, which is the same as the first term. Plus nc1, 3 to the power 1, same as the second term. Plus dot 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 ncn, 3 to the power 0, so same as the last term. ncn 3 to the power 3 to the power 3 to the power 0, 1 to 3 to the power n. Last term. Can you see this is the same as this? So it's coming in the same order if you write as 1 plus 3 the whole to the power n. So you can write LHS is equal to RHS. In the left hand side you're putting 1, 2, 3 and writing it like this. And then expanding 4 to the power n as 1 plus 3 whole to the power n, and you see that they are exactly the same. You don't have to solve it, just so show it and leave it like that. So let's go to the first sum. The first few sums that I didn't do, 1 minus 2x the whole to the power 5. I didn't do this sum, right? Let's expand this. Let's keep it as x minus a the whole to the power n. So you know the formula. Oh, sorry. You know the formula. 5c0. 1 to the power any number ignore. 2x the whole to the power 0. Minus 5c1. 1 to the power any number ignore. 2x the whole to the power 1. Plus 5c2. 2x the whole to the power 2. Minus 5c3. 2x the whole to the power 3. Plus 5c4. 2x the whole to the power 4 minus 5c5 2x the whole to the power 5. So let's find what is this. 5c0 is 1. Any number to the power 0 is also 1. 5c1 is 5 into 2x is just 10x plus 5c2 you know is 5 into 4 by 2 n into n minus 1 by 2 10 into 2x the whole square. 10 4s are 40 into x square. Minus 5c3 is the same as 5c2 because ncr is the same as n minus r. So 5 2s are 10, but this is 2 to the 4 4s are 8, so 80 into x to the power 3 plus 5c4 is the same as 5c1 which is 5 2 2s are 4 4 2s are 8 8 to 16 16 5s are 80 x to the power 4 minus 5c5 is 1 2x the whole to the power 5 is 2 2s are 4 4 2s are 8 8 to 16 6 2s 32 32 into x to the power 5. This should be the answer. Okay, so this is so simple. So let's go to second sum. I hope it's recording. Yeah. Okay, so let's go to second sum. Using binomial theorem, expand 2 by x minus x by 2 the whole to the power 5. So as usual, you see a negative sign, you have to alternatively write positives and negatives. Okay, it's 5c0, 2 by x the whole to the power 5 into x by 2 the whole to the power 0 minus 5c1, 2 by x the whole to the power 4 into x by 2 the whole to the power 1 plus 5c2 into 2 by x the whole to the power 3 into x by 2 the whole to the power 2 minus 5c4, 2 by x the whole to the power 4 into x by 2 the whole to the power 1. This power has to be descending 4 3, then this should be 1. What about 3? So 2 and this will be 3 plus 5c4 2 by x the whole to the power 1 and x by 2 the whole to the power 4 minus 5c5 2 by x the whole to the power 0 x by 2 the whole to the power 5. Just solve this and you get the answer. Okay, you know that this is 2 2s are 4, 4 2s are 8, 8 2s are 16, 32. 32 by x to the power 5. That's the first term. Next one is this is 5, 5c1 is 5. The denominator 2 and this power will get cancelled only for 2. It's 2 to the power 3, 2 2s are 4, 4 2s are 8, 8 5s are 40. But x will still have a power 4 and that will get cancelled with this x, and so it will be x cube. Like this, when you solve, you get 20 by x minus 5x plus 5x cubed by 8 minus x to the power 5 by 32. Just solve it and see. Okay, so that's that question. So let's go to next question, which is using binomial theorem, solve 2x minus 3 the whole to the power 6. And there's a minus sign similar to the first sum. So then it's 6c0, 2x the whole to the power 6, 3 to the power 0, minus 6c1, 2x the whole to the power 5, 3 to the power 1, plus 6c2, 2x the whole to the power 4, 3 to the power 2, minus 6c3, 2x the whole to the power 3, and 3 to the power 3, plus 6c4, 2x the whole to the power 2, and 3 to the power 4, minus 6c5, 2x the whole to the power, subtraction is 1, and 3 to the power 5. Just write it like this, and a 6c6 with the plus 6c6, 2x the whole to the power 0, 3 to the power 6. Just solve this. It's so easy to solve it, and you will get an answer. Here's 2 to the 4, 4 to the 2 to the 64, right? X to the power 6 minus, in this this is 6 and this is 3, 3s are 18, 2 to the power 5 will become 576 into x to the power 5. I'm writing the direct answer. Just sit and calculate and you get the answers. 4320 x to the power 3 plus 4860 x square minus 2916 x plus 729 is the answer. So let's go to next sum. The fourth question is x by 3 plus 1 by x. Using binomial theorem, solve x by 3 plus 1 by x whole to the power 5. It's only with a plus, so everything can be plus. 5c0, x by 3 the whole to the power 5, 1 by x the whole to the power 0, plus 5c1, x by 3 the whole to the power 4, 1 by x the whole to the power 1, and next is 5c2, x by 3 the whole to the power 3, 1 by x the whole to the power 2, plus 5c4, x by 3 the whole to the power 1, 1 by x the whole to the power 4, plus so I forgot the 5c3, plus 5c3, x by 3 the whole to the power 2, and 1 by x the whole to the power 3. Can you see? I'm just quickly writing it because of this. And a 5c4, x by 3 the whole to the power 1, 1 by x the whole to the power 4, plus 5c5, x by 3 the whole to the power 0, and 1 by x the whole to the power 5. Just solve it, you get the answer. As simple as that. You know, 5c0 is 1, 5c4 is 5, 5c2 is 5 into 4 by 2, 5 into 4 by 2, 10, 5c3 is same as 5c2. So you can copy the corresponding thing, and you get x to the power 5 by 243 plus 5x to the power 3 by 81 plus 10x by 27 plus 10 by 9x plus 5 by 3x cube plus 1 by x to the power 5. Very, very easy to solve this. So solve it and get the answer. Let's go to next sum. Using binomial theorem, solve x plus 1 by x the whole to the power 6. So 6c0, x to the power 6, 1 by x the whole to the power 0, plus 6c1, x to the power 5, 1 by x the whole to the power 1, plus 6c2, x to the power 4, 1 by x the whole to the power 2, plus 6c3, x to the power 3, 1 by x the whole to the power 3, plus 6c4, x to the power 2, 1 by x the whole to the power 2, plus 6c5, x to the power 1, 1 by x the whole to the power, sorry, this has to be 4 and this has to be 5. We have to copy this there. Plus 6c6, x to the power 0, 1 by x the whole to the power 6. Just solve this and you get your answer. It's as simple as that. It's x to the power 6 plus 6 into x to the power 4 plus 15 into x square plus 20 plus 15 by x square. This completes the first exercise. Just make sure you're so thorough with this and let me continue with the next exercise in the next video.